Imagine something so impossible that when it happens, the first reaction isn't wonder, it's denial. You wake up one morning and look at the news and see something that should take thousands of years happening in a single night. The entire California coastline from San Francisco down to Los Angeles has risen 6 feet. Not gradually, not over decades, but overnight. Beaches are suddenly stranded above the waves. The sea has retreated as if the ocean itself decided to step back from the land. Ports that were bustling with activity just hours before are now sitting on exposed mudflats. Container ships worth hundreds of millions of dollars are literally stuck on the ground, unable to reach the water. It sounds like science fiction, but here's what's truly remarkable. Every instrument we have, everything we've built to measure the Earth's subtle movements is telling us the same thing. Let me explain why this matters, because this gets at something fundamental about how we understand our planet. You see, we've become obsessed, rightfully so, with measuring the Earth with incredible precision. We have GPS stations scattered across the coastline, satellites in orbit constantly mapping the terrain, tide gauges recording every millimeter of ocean movement, and old-fashioned leveling surveys that scientists have been conducting for over a century. These aren't crude instruments. We can detect movements of less than the thickness of a human fingernail. That's millimeters. At NASA's Jet Propulsion Laboratory, where I've worked and collaborated with brilliant minds, they can track vertical motion with extraordinary accuracy. It's the kind of precision that allows us to know if the ground beneath San Francisco is rising or sinking by just a few millimeters per year. And here's the thing about California's coast. It's always been in motion. The Pacific Plate and the North American Plate meet right there, grinding past each other in a never-ending dance that's been going on for millions of years. Most of the time, this motion is almost invisible. We're talking about creep rates of 0 to 4 millimeters per year. That's it. A lifetime to notice even a few inches of change. In some places, like Santa Barbara, the land rises at about 3 millimeters per year. That's roughly the thickness of a credit card, and it takes a full year to get there. In other places, like Long Beach, human activity actually causes more movement than nature does. Oil extraction, groundwater pumping, these things can nudge the land up or down by a few centimeters, but again, it's gradual. Most of California's coast actually sinks rather than rises as groundwater gets drained and sediment compacts beneath the weight of cities. So when the instruments started showing vertical jumps of 6 feet in a single night, something broke in the understanding of how the world works. Now, I want you to appreciate what this means. These GPS stations, they're built on concrete monuments anchored deep into bedrock. They're designed to be as stable as possible. Their data gets cross-checked against satellite radar, against tide gauges, against independent measurements. Every layer of validation reinforces what the other one says. When you have this kind of redundancy, when every single independent system confirms the same impossible measurement, you can't just dismiss it as error. The odds of every instrument failing in the same way, at the same moment, are beyond calculation. The seismic networks were silent. No earthquakes, no tremors, not even a minor blip on any seismograph. The land just rose quietly, everywhere at once, without shaking, without warning, without any of the signatures we associate with major geological events. This is where the investigation becomes fascinating. The engineers and scientists at JPL, at the United States Geological Survey, they did exactly what you're supposed to do when you get impossible data. They audited everything. They went back and retrieved the original raw files from every GPS station. They checked the antenna types, the maintenance histories, the soil conditions beneath each monument. They looked for misalignments in the global coordinate system that might create the illusion of uplift. They analyzed the atmospheric data looking for tropospheric corrections gone wrong, ionospheric spikes from solar activity. Any of these things could introduce errors of centimeters. But a 6-foot vertical leap, that dwarfs any known atmospheric artifact by orders of magnitude. Then they looked at phase unwrapping errors in the radar interferometry. In satellite radar, you have to interpret how many times the radar wave has wrapped around as it bounces off the ground. Get that calculation wrong by even one cycle, and you see a vertical cliff where there's only a gentle slope. But the team ran coherence checks across hundreds of radar frames, and the uplift wasn't isolated to pixels or edges of low coherence zones. It stretched in a perfect unbroken line for hundreds of miles. Across city blocks, farmland, rocky headlands, one continuous signal. The tide gauges, which measure sea level relative to land, reported the same sudden drop in water height, mirroring the rise seen on shore. Every independent measurement, cross-validated by different methods, different agencies, different types of instruments, all telling the same story. And this is what kept scientists up at night. The usual culprits, the things that normally explain away anomalies in geophysical data, couldn't explain this. So you're left with two possibilities. Either the data is real, or the world's most advanced monitoring networks have failed in their primary function. And if the data is real, then something happened to the planet that no one can currently explain. Now, in all of this chaos, people remembered something from the past. About 40 miles south of Los Angeles, there's a place called Portuguese Bend. In 1956, residents woke to find cracks zigzagging across their lawns and roads. Over the next 7 months, the ground shifted more than 22 feet, not globally, not along the entire coast, but locally. 140 homes were damaged or destroyed. People described it as living on a slow-motion conveyor belt that never stopped, just paused and lurched forward with each new rainstorm. That ancient landslide never fully settled. Decades passed, but the ground kept creeping, sometimes an inch a week, sometimes faster. Then came the winters of 2022 and 2023. California was pummeled by storms that dumped more than twice the usual rainfall. That water soaked deep into the clays beneath the hills, recharging old slide plains and pushing groundwater tables to levels unseen in living memory. Sensors recorded the land moving at rates up to 30 centimeters per week. That's 10 times faster than anything in the historic record. The landslide zone expanded from 380 acres to over 700. Entire neighborhoods were swallowed as the land continued to move, not just at the surface, but deep underground. Boreholes revealed a new, deeper sliding layer that had lain hidden for decades, now activated by the weight of all that water. And this is the key insight. At the leading edge of a landslide, at what geologists call the toe, something remarkable happens. As a massive block of earth grinds forward toward the coast, its front slams into harder, unyielding rock. The result is compression so intense that the ground itself begins to buckle upward. Toe uplift, the physical bulging of the earth, where the advancing material can't move forward, so it moves up. This doesn't require an earthquake or a volcanic eruption. It just requires water, gravity, and the stubborn geometry of a coastline where immovable objects meet irresistible forces. But here's what troubles scientists most. Even if Portuguese Bend explains some localized uplift, it doesn't explain what happened along 400 miles of coast. The Portuguese Bend mechanism works at the scale of tens of miles at most. The water, the sliding plains, the toe compression, all of these are localized phenomena. They don't propagate for hundreds of miles. A landslide doesn't care about Los Angeles. It doesn't know about San Francisco. It works where the water's soaked in, where the slide planes exist. So while Portuguese Bend demonstrated that rapid uplift is physically possible, it opened rather than closed the greater mystery. When the ports went dark, when container ships found themselves stranded on exposed ground, the economic cascade was immediate. More than $1 billion a day in trade ground to a halt. Fresh produce that should have been shipped across the country sat rotting. Electronics that should have reached American manufacturers were stuck in limbo. The nation's busiest ports were crippled in a single night. On the beaches, the environmental devastation became clear even faster. Tide pools that had sheltered marine life for generations were baking in the sun, unreachable by the receding ocean. Marine biologists from institutions like Monterey Bay Aquarium organized rescue teams with buckets and wet towels, trying desperately to save what they could. But the scale overwhelmed them. Hundreds of seabirds and seals floundered where the surf used to break. For every animal saved, dozens more perished. And then the politics began. GeoStride, a Silicon Valley satellite analytics firm, released their own data within hours showing the same 6-foot vertical leap, but with even sharper precision than government networks. The United States Geological Survey fired back with a rare public statement warning that satellite-only measurements could be distorted by atmospheric interference or software bias. GeoStride accused the USGS of clinging to outdated ground sensors and ignoring evidence visible from orbit. Scientists traded barbs over calibration protocols. News outlets published leaked emails. The Department of Defense issued denials about secret drilling or underground detonations, but rumors refused to die. Insurance companies saw claims spike by billions in a single day. Policies that once covered earthquakes or tsunamis were suddenly worthless, voided by a disaster with no name and no precedent. The question became not just what happened, but who controlled the narrative of reality itself. If the data was right, then the rules of geology had been broken. If it was wrong, then the world's most advanced monitoring networks had failed in their only essential job. With every new press release and technical rebuttal, the gap between the camps widened. So what does this mean? What are we actually looking at here? The honest answer is that we're looking at something that challenges how we understand the mechanisms of Earth itself. We have data from multiple independent systems, all cross-validated, all pointing to the same impossible events. We have localized precedents, like Portuguese Bend, that prove rapid uplift is possible at small scales, but nothing that explains this scope or this uniformity. We have no seismic activity to account for it, no volcanic signature, no explanation that fits within our current models of how the planet works. This is where science goes when it encounters the impossible. You don't dismiss the data. You embrace the mystery. You gather more information. You build new models. You challenge your assumptions. Because every major shift in human understanding has started exactly here, with measurements that don't fit the framework, with reality insisting on being stranger than our theories predict. The California coast remains lifted. The cause remains unproven. And the question of what comes next remains a matter of urgent, unsettled inquiry. And that is precisely why this matters. Because the ground we stand on, the predictions we make, the frameworks we build our entire civilization upon, they all depend on understanding our planet correctly. When that understanding fails, everything becomes uncertain. And uncertainty in the face of planetary forces is the most honest position science can take.